Hi, in this lesson we are going to take a look at graphing both by hand and using the calculator. Actually, we're going to try and introduce you to several features of your graphing calculator that will be very handy as we go through the rest of the semester, trimester. We're going to begin by asking you to graph the line y equals 4 minus x. And folks, there are many ways that you have learned to graph lines. You could build a table of points. You can put the line in slope-intercept form. You could find the x and y intercepts of this line, and all of those would lead to a graph. I think I'm going to do what many of you would do, which is rewrite it so that it looks like it's in slope-intercept form. That is, I want the x term to be up front, negative, and I'm going to put a 1 there, negative 1x plus 4. These two are equivalent, and of course in slope-intercept form, the slope tells us how far up and over, and this says that we should go down 1 when we go right 1, starting from a y-intercept or a starting point of 4. So I'm going to plot the point y equals 4, that's our y-intercept, and then I'm going to follow the slope direction to find other points on the line. Down 1, right 1, down 1, right 1, and I'm going to do that several times so that I get a real good guide about where to draw my line. Hey, I almost got that one straight. Alright, many of us will remember graphing lines in just that way. The next activity in our notes asks us to build a table to graph all the points that satisfy the equation y equals the absolute value of x plus 1. Now, we are going to build a table, but I'd love to have you see how the calculator can help you out with that. So excuse me while I get my calculator up. Okay, let's get back to that. We can build a table using our calculator that would allow us to graph either by hand or on the calculator, so we'll show both. However, to build a table, you want to get into your y equals, that's your equation editor, and what we want to put in there is this, the absolute value of x plus 1. Now, absolute value for the Texas Instruments calculator is under the math key, so I press math, I arrow over to number, and you'll notice ABS right there. That's the function we want. So we're going to graph the absolute value of x, and the x key is right next to the alpha key, x plus 1. Alright, now that we have that in our equation editor, to view a table or to set up a table, second and window, I'm going to ask my table to start not at 1, but I'm going to ask it to start at like negative, I don't know, 5. And go up by 1s. Then to see the table, it is second and graph. And here comes a table of points that I can graph to get a picture of this function. So I'm going to just copy down a few of them, not all of them. And let's see, at negative 5, y is 4. At negative 3, y is 2. At negative 1, y is 0, and that's going to be an important point for us, so we want to make sure that we graph that one. When x is 1, y is 2, and you can see as we skip 2 over here in x's, we're also skipping 2 here in y's. The absolute value function then has as its bounce place, if you will, negative 1 and 0, so instead of being situated at the origin, it's been shifted to the left 1. I want you to keep that in mind, because later in this chapter we're going to talk about how you can tell from the rule what's happened to that absolute value function. Negative 3, we are at 2. Negative 5, we're at 4. 1 and 2 is on the graph, and I'm betting that you guys already will know this, but if I were to put 3 here and think 3 plus 1 is 4, and the absolute value of 4 is 4, we could go on building that table by hand as well. But right now we have a good picture of what that absolute value v is doing in the coordinate plane. And we did that by graphing points from a table. Again, to set up a table, it is second and window, and that's the table set function. To view the table, it's second and graph, and that's to, again, to view the curve, or view the table. if we wanted to go ahead and check our curve with what we've got on the screen, we could do that for sure as well. The window that we would be wanting to look at is the same one that shows on your paper, negative 10 to 10, negative 10 to 10, and if we hit graph here, we'll see that absolute value V, sure enough, and we tagged it. Graphing Calculator is wonderful, and we are going to just introduce you to several of its features today. Next, we have a graph that some of us might not be sure what this looks like. Okay, a cubic, I'm not sure that you remember that, and it has a negative coefficient on in front. I'm not sure what it looks like. Well, kind of I am. I know it's going to have some shape like this. It's going to have a whoop-de-doo, and it's going to start high and drop low, but we'll learn more about that in this unit. Let's just put that in there though. Negative, and x is right next to alpha, negative x cubed, so the caret key is the raised 2 key, and we want to be to the third power, minus 2x squared plus 10x plus 12. And it says find an appropriate viewing window and answer the questions that are here. Well, if you're not sure where to start, that negative 10 to 10 in both directions. So I'm writing this in how our book shows it. This would be the x min, x max, and the step that you're going by. For x's, negative 10 to 10. For y's, negative 10 to 10. That's always a good place to start. Now you can always adjust that window if you need to, and you would do that using the window key. Okay, but I'm going to try that here and see if I see all the features of my graph that I need. Oh, see, I'm missing just the very top of that. I'm going to go back there and get that. So I'm going to change my window. I need it to go higher in the y direction. So instead of going to 10, I think I'm going to change it to go to 20. And I also am going to change the scale, that is the step, because if you don't, it gets real cluttered looking around the axis. So let's see if we've got the whole thing here. Oh yeah, we've got the entire upsy-downsy is what I call it of this thing. And we want the y-intercept. At least that's the first thing that I asked for. I'm going to use my calculator's trace button, and that's the fourth one from the left, right next to the graph key. Trace, I chose that because it will come up if you have a symmetric or semi-symmetric graph. It'll come up sitting right on that y-intercept. When x is 0, y is 12. So the point 0, 12 is the y-intercept there. You could also remember that's that constant in the rule. X-intercepts are where we cross the y-axis, and they are called x-intercepts, they are called zeros, they are called roots. All of those things mean the same thing, and that is the location where it crosses through the x-axis. There are 3 intercepts here. I want to show you how your calculator can find those as well. Second, and trace this time. And you can see there's a whole bunch of stuff you can do with a graph, but we want the zeros of this function. So I'm going to go to the number 2 function there, 0, and press enter. And it looks like it's asking you a question here. What's the left boundary? Well, I'm going to go for this root right here, which looks like 3. I'm not sure if we're going to find that it's exactly 3 or maybe not, but the calculator will tell us. So we're going to get our cursor so that we are close to the root and yet left of it in x territory, and then we're going to hit enter. Then we're going to arrow to the right until we pass the root, and then hit enter again. We're setting a right boundary, it says. See what you've got, those 2 boundaries that you set. It's going to give you the only place between those 2 values of x where y is 0. You don't want to guess, you want to know, so you press enter. And oh, it was not 3. Okay, if we would have written 3, we would have been off by a little bit, folks. It's around 2.89. So it has one root at around 2.89. And it has 2 other roots that we can find using the same technique, or I could show you a little different technique as well. So I'm going to go back to second and trace, and I'm going to go 0. And I'm going to have to move my cursor a long way, so I got to get it up and over the bump, and I want to get so that it's to the left hand side of the root that I'm interested in, so right about in there. You might think under the root. Press enter, arrow past the root that you want, press enter again, and then one more time. And that one, which I thought was at -1, is really at -1.09 approximately. There is 1 0 left to find. I'd love to show you an alternate method of finding that root. I'm going to go back to my y equals, and I'm going to put into, see, I'm interested in this function when y is 0. So I'm going to put the y equals 0 line in there. And that's just a flat line. Actually, it's the x-axis. So I've just told it that this is a line that I want it to look at. I want to find this root, and I'm going to do the second and trace again, but instead of 0 this time, I'm going to go for intersect because I've got a curve and a line in there, and what I want to know is what their intersection is right here. So to get here, I want to get close to the intersection. Okay, I don't have to be right on it, but I have to be close. And then I'm going to hit enter. First curve. The second curve is the line, and I'm going to hit enter there. And now I don't want to guess, I want to know. And that intersection is at -3.8 approximately. And that's just another way to find a 0, and we did that by using the intersect function. It's time to write some things down here. The y-intercept we found by pressing just trace, and we looked for the spot where x was 0. To get the x-intercepts, we used second trace and 0. We also used second trace and intersect. To find the value of y when x is -5, that also is a second trace function. Now I know that you could use this, you could do this algebraically, just stick a -5 in here, but that's a lot of computation. Our calculator can do that if we know a specific x value that we're interested in. It's the value function, the number 1 thing up there. So when I press enter, it'll ask me to input the x that I want, -5. And when I enter here, it tells me that y is 37. That's not even, our graph isn't even showing that high, right? But we do have an x of -5, so way up there at 37. We did that time, so when we know x, second trace and value. This is when we know x and want y. This is the opposite. We want to know the value of x when y is 3. A good way to do this, see, that's not built into the second trace thing, but we can use that intersect function again. Instead of having the y equals 0 line, I'm going to tell it to give me the y equals 3 line, and here comes my graph. Oh, look at that. There's the y equals 3 line, and 1, 2, 3 times we would get 3 values for this. I'm not going to find them all, but I will just remind you. Second and trace. Intersect is the thing that we want. We move our cursor close to the intersection we're interested in. So I'm going to go for this middle one. We hit enter, enter, enter. And when y is 3, x is approximately -0.82 right there. You could find the other 2 by doing the same procedure, and I'm not going to do that. However, second trace and intersect. We use second trace and intersect when we want x, but we know y. Alright, so we've just given you just a brief introduction to the power of your graphing calculator. It can do a lot for you. And then we're going to, one more thing in this lecture today. we want to talk a little bit about interpreting line graphs, since we're talking about graphs in this section. So get a little statistics in there on you. This graph is showing the average or the mean number of days which a single family dwelling, that's a house, okay, either a freestanding house or a condo, was on the market in Dane County, Florida, I think, for a specified month. And blue here is the single family, red is condo, and line graphs, folks, in general are really good for showing trends. That's why statisticians use them. They show trends over time. And we've got just a couple of questions to answer. The mean number of days for which a condo, so that's in red, was on the market in October of 06. So here's October. There's the condo thing, and how nice of them. They have it even marked there. 122 days on the market, so around 4 months. Any trends that you see? I'll tell you what, if this is the number of days on the market, as you go through time, you can see that houses are selling faster. They're on the market less days. And at this particular time, condos were spending more and more time on the market. Condos were not selling well. All right. That's it for today, and we're going to ask you to get out there, try the U-Try as quickly as you can, and we'll see you in class.